So in this video we're going to be looking at binomial distribution. Here's how you set up a binomial distribution. So you see that x is binomially distributed, and then you need to know the number of trials you're carrying out and the probability of success. In order to use this, you have to have a fixed number of trials, that's your n value, two possible outcomes, success and failure, a fixed probability of success, your p, and then the trials need to be independent of each other. So that means that if I run one trial and it's successful, that wouldn't affect whether the next one is successful or not. Once you know that you can use a binomial distribution, you can then work out your probability mass function using this formula here. So the probability that you have some number of successful trials being r is going to be nr, so this is combinations, n choose r, where n is your number of trials and then r is the number of trials that you want to be successful. The probability of success to the power of r, and then 1 minus the probability of success, so this would be the probability of failure to the power of n minus r, so how many trials you want to fail. It's easier seen with an example. So we have one here, so we've got a binomial distribution. I'm running 12 trials and the probability of success is 1 over 6. So for instance, I might be rolling a dice 12 times. The probability of me getting a 6 is 1 over 6, and then I want, okay, what's the probability that I have 2 6s out of my 12 rolls? So you can set this up like so. We're going to have 12 choose 2. So what this means is how many ways are there selecting 2 objects out of 12, multiplied by the probability of success, which is 1 over 6, to the power of the number of trials we want to be successful, so that's 2, and then the probability of failure, 5 over 6, to the power of the number of trials we want to fail, so 12 minus 2, 10. And then I can use my calculator to work this out. So we're looking for this button here, my combinations button, which is above my divide. And then I want to know my n value is 12. I'm going to press shift, combination 2. So that's 66. So there are 66 ways for me to choose 2 objects out of 12. And then I need to multiply that by 1 over 6 to the power of 2. And then multiply again by 5 over 6 to the power of 10. And then my answer is 0.296. So this is the probability that I would have 2 successful trials when I run the trial 12 times. So we can do the same thing here for x is 9. So this is what's the probability that I have 9 successful trials out of my 12. There's another way we can work this out on the calculator. So instead of doing all of this by hand, our calculator has a function to work out for us. If I go into my menu, and then I'm looking for distributions, which is this one here, equals, and then you've got several options here depending on what kind of distribution you want your calculator to work out. We want binomial, so I'm going to select option 4. And then we want to select variable, so option 2. And then here it will work out my binomial distribution for me. My x value, in my case, is 9. So I'm going to put 9 in here. And then equals. How many trials am I running? 12 equals. And then the probability of success is going to be 1 over 6. And then here's my answer. It's given to me in standard form. I can write that as 0.0000126. So this is the probability that I would roll 9 6s out of 12. And then here we want the probability that x is less than or equal to 1. If I wanted to work out this way, then I would work out the probability that x is equal to 0 plus the probability that x is equal to 1. So you could come and work out these two things individually using this calculator method and then add those together. Also, your calculator has another function that will work out this for you. So if I go, let's go back into the menu again, distribution, there we are. And you can see here you've got normal PD, normal CD. We've also got binomial PD here. If I scroll down, I can see I've got binomial CD. This is the binomial cumulative distribution. And so this will work out the same thing, but your x value, instead of working out x is equal to that value, it will work out x is less than or equal to that value. So if I go into binomial CD here, 1, and then again I want variable, 2, and I'm going to put in x is 1, my number of trials is still 12, my probability of success is still 1 over 6, so these can remain the same, and then equals. So this here has worked out the probability that x is less than or equal to 1, instead of working out the probability that x is equal to 1. And so that's 0.381. But equally, you could have come along and worked out these two things individually using the binomial PD function and then added them together. So what I'd recommend you do now is have a go at these here. Pause the video, you've got your binomial distribution, 8 trials, probability of success is 1 over 3, and then you're working out x is equal to 2, x is equal to 5, x is less than 1. What I would recommend is to work out one using this method, and then work out the other one using your calculator. Okay, so pause and have a go. And then hopefully you've got these as your answers. So you should have number 1, 0.273, 0.0683, and then 0.195. Okay, we have an example here. The probability that a randomly chosen member of a reading group is left-handed is 0.15. A random sample of 20 members of the group is taken. Find the probability that exactly 7 of the members in the sample are left-handed. So here we've got a fixed number of trials. My number of trials is 20. I've got 2 possible outcomes. So in this case, left-handed or right-handed. A fixed probability of success, which is 0.15. And the trials are going to be independent of each other. So if one person selected as left-handed, then it doesn't mean the next person was more likely to be. So I can set this up as a binomial distribution. We'll call my variable x. And then you have this little tilde sign. I'm doing a binomial distribution. I want my number of trials to be 20. And then we'll call left-handed success. So therefore, success is going to be 0.15. Now I need to build my problem. So I want the probability that x, I want exactly 7 of the members to be left-handed, is equal to 7. And then you can come along again with your calculator and either do it the long method or the short method. I'll do the quick way. So I want, this is x is equal to 7, so therefore I'm going to use the PD rather than the CD. So 4, 2 variable, and then I want x is 7, number of trials is 20, and the probability says 0.15. And my calculator's worked it out for me. 0.0160. Done. So you've got one to have a go at here. The probability of a switch being faulty is 0.08. A random sample of 10 switches is taken from the production line. Find the probability that the sample contains 4 faulty switches. So you're going to have to do the same thing as I did up here. First of all, build your problem, your binomial distribution. Think about what your n value is and your p value. And then you want the probability that x is equal to some number. So pause the video and have a go at that. And then here you have your solution. Thanks very much, everyone.